Generator connection accessories. Excitation transformer cubicle. Introduction. Most large turbo generators have static excitation systems. The excitation transformer cubicles are connected to the generator terminals through a tap-off connection from the main isolated phase bus. This tap-off connection is the closest to the generator terminal. The enclosure of the excitation transformer cubicle is insulated from the tap-off connection by rubber bellows. An enclosure bonding bar is installed close to the rubber bellows. The conductor is connected to the terminals of an excitation transformer cubicle with a flexible connector. When the prospective fault currents are high, no protective device such as fuse can be installed. The excitation system comprises a dry cast resin, 3-phase transformer. The output of the excitation transformer is connected to the input of a rectifier cubicle by a compact AC busway. The output from the rectifier cubicle is connected to the generator field winding terminals by a compact DC busway. Excitation transformer. The 3-limb transformer have independent primary and secondary windings that are individually cast. The high voltage and low voltage coil assembly has air as the primary insulation. This air column also acts as a cooling duct with natural or forced air cooling. The primary coils are connected in delta and the secondary in star. Cooling fans are installed at the bottom of the coils. The connection inside the excitation transformer to the incoming high voltage terminal of the coil is extremely critical. It should be well insulated and adequately supported. For large-sized generators, it may not be possible to size the cross-section to meet the short time rating of the tap-off bus. The short-circuit forces are likely to be extremely large in the event of a line-to-line or 3-phase fault, and hence the connections must be brazed to withstand the same. The output of the excitation transformer is connected to the input of a 3-phase rectifier cubicle. In the past, the AC power connection from the excitation transformer secondary to the rectifier unit were carried out with copper cables. Each phase had several cables running in parallel. Now the AC connections are being carried out with busways with copper conductor. These are very compact connections and suitable for routing near the generator foundations. These connections are extremely sacrosanct and care is required in establishing their reliability. It is advisable to specify a single copper conductor to carry the rated current. The output from the rectifier cubicle is connected to the generator excitation winding terminals. In the past, the DC power connections from the rectifier cubicle to the generator excitation winding terminals were carried out by copper cables. Each pole had several cables running in parallel. Now the DC connections are being carried out with busways with copper conductor. These are very compact connections and suitable for routing near the generator foundations. These connections are extremely sacrosanct and care is required in establishing their reliability. The ventilation near the generator excitation connection is likely to be poor. The rectifier output will not be a pure DC but will contain harmonics. These will generate additional heat in the conductor. It will also generate additional heat due to the induced eddy currents losses in the enclosure. These should be considered while sizing the conductors. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to Bala at busbarsystems.net.